All right, guys, this is going to be a short video which is going to start off a section on trig identities, and we're going to kind of keep it basic right here. If you look, I have the 6 trig functions, and I have them linked up with its reciprocal trig function. All right. Now, what we've dealt with so far is in the unit circle, we've said that cosine's x and sine is y. And then we've built off of that, and we can put everything in terms of x and y. For example, cosecant, you can see is the reciprocal of sine. Well, another way to look at it is this. Instead of saying it's 1 over y, we could say it's 1 over the sine of whatever angle. Looks like I'm using angle A here. Sine, another way to look at that, that's 1 over cosecant of A, right? That's basically just like saying they're reciprocals of each other. Secant, which we did in the unit circle, is 1 over x. We can replace that with 1 over cosine. And then another way to look at cosine is to say it's 1 over secant. Tangent and cotangent, I believe in the unit circle what tangent was y over x and cotangent was x over y. This is another way of looking at it, that these are reciprocals. Cotangent you can say is 1 over tangent, and tangent is 1 over cotangent. All right, so you'll see once we know, and this is kind of review, once we know a value for a trig function, to get the value of the same angle at its reciprocal function, you just flip the fraction. All right, and we've done this before. So this is, like I said, still kind of a review. The big thing is that all these are in terms of trig functions. They're not in terms of x and y in the unit circle. All right, so we actually look at a couple problems when we use this. For A, right here in this first section, okay, we have if tangent of A is 0.8, find cotangent of A. Well, I know these are reciprocals of each other. So one way to look at it is to just say, all right, cotangent of A is this right here, is 1 over tangent of A. Right, that's the reciprocal. So I could say it's equals 1 over 0.8. If you put that in your calculator, you should get 1.25. So that should be the answer for cotangent. An easier way to do it is, especially since we're dealing with reciprocals, it's much easier if it's written as a fraction rather than a decimal. So 0.8 is what, 8/10, which simplifies to 4/5. This is just like saying tangent of A is 4/5. So to get cotangent of A, you just flip that, and it becomes 5/4 or 5/4, and that's the same thing as this 1.25. All right. Now, when I move to B, this is actually a typo because remember the parabola's secant is always bigger than 1, or the other parabola that goes down, it's less than -1. So this is that can never equal 3/4. Let's just say it's 4/3, okay, because that's bigger than 1. Now to get cosine, it's the reciprocal of secant. So very, very simple. It's actually what I just drew over right there. You just flip the 3/4. Or excuse me, you flip the 4/3 to give you the 3/4. All right, I didn't have to draw a right triangle, which we're actually going to do in the next section. But if you have a trig function, its value, and you want to find its reciprocal, it's very, very simple. You just flip the fraction. All right, the second part, which will be the last part that we go over, is what's called quotient identities. And I kind of mentioned it with tangent and cotangent. Tangent in the unit circle was y divided by x. And usually y, right, y in the unit circle sine, x is cosine. So this is another way to look at it, to say sine over cosine. Cotangent in the unit circle was x over y. So therefore that's flipped, right? And I know cotangent is reciprocal of tangent. So this is cosine over sine. All right. Um, the reason why we'll use these, and you'll see it after this video when we get back to the notes, when we get back to class on Monday, is you can take any trig function and you can put it in terms of sine and cosine. Just like any trig function in the unit circle, we can put in terms of x and y, but when I put it in terms of trig functions, I can put it in terms of sine and cosine. All right. Okay, so last thing, these are still kind of review right here. Now it's saying if tangent of A is 2/5, find cosine of A, and it's always going to be the same angle. Like I wouldn't give you tangent of A and then ask you to find the cosine of B. All right, it's going to be the same angle. Otherwise, you can't work with it. And we're going to assume the angle A is in the first quadrant. We're going to keep everything positive. So in order to do this, now I don't have any identities yet. The reciprocal identity I can't use. For cosine of A, this is where you have to draw the triangle. And actually, no, even before I do that, because I kind of just mentioned this right here, I'll show you a common mistake. Some students will look at this and say, oh, this is easy. Since tangent is sine over cosine, then cosine has to be 5. And if you found the sine of A, it would be 2. Because then when you do sine over cosine, it's 2/5. But remember, when we do sine and cosine, they can never be bigger than 1. That's the biggest value you can get for sine and cosine is 1. So everything has to be proportional. This we cannot do. All right. So the only way to do this is we're going to draw a right triangle. And it really doesn't even matter how you draw. I'm going to keep everything positive, all the sides. Let's say I put angle A here. Well, this is what, just going back to SOHCAHTOA. This is TOA right here. So opposite over adjacent. So the opposite is 2. The adjacent is 5. And then to figure out any trig ratio, you have to find the hypotenuse. So we just use Pythagorean's formula, right? Doing 2 squared plus 5 squared equals the hypotenuse squared. So that left side would give us what, 29? And then you would have to take the square root of it. So that hypotenuse is going to equal the square root of 29. All right, I'll even put this in here. I'll just erase where I have hypotenuse, and I'm going to put square root of 29 in here. Now to do cosine of A, we just use SOHCAHTOA. Cosine is adjacent over hypotenuse. So adjacent of angle A is 5. The hypotenuse we figured out is root 29. So this is 5 over root 29. But then remember, you want to rationalize it. You don't want to be left with the square root at the bottom. So we multiply top and bottom by root 29. And we wind up getting 5 root 29 over 29. All right. And that is less than 1. All right. And we've kind of done that before, and you probably even did that in geometry. Okay. Now, when we go to B, this actually is a lot easier because if you look at it, you have the 3 and the 5. This is going to be a 3, 4, 5 triangle. Let me see if I can slide this over. Yeah, I'll put the work above it. So if I draw this triangle, okay, let's say this is angle A. This is adjacent over hypotenuse. So the hypotenuse is 5, the adjacent side is 3. And you get a Pythagorean triple there. You get 3, 4, 5. So the opposite side is 4. Now, if I want to find the sine of A, I just do opposite over hypotenuse. So in this case, it's what, 4/5, right? And that makes sense because it's less than 1. Sine and cosine always have to be less than 1. And then cosecant, we kind of go back to the reciprocal identities. Cosecant is the reciprocal of sine. So this is 5/4. All right. So really, these quotient identities, I didn't use these yet, but I will use these in class on Monday. I guess really just kind of main things we went over. Number 1, the reciprocal identities, where you just flip it. And number 2, if you can't use a reciprocal identity right away, then you have to draw a right triangle.